Hello, welcome back to Mrs. Torres' YouTube channel. Today, we are going to do a few quadratic application problems. So we're going to use all of that knowledge on quadratic equations and plug it into a real life application. All right, the first one says, the formula for a ball tossed in the air is h of t equals negative 16t squared plus v of t plus s, where v is the starting, this should say, velocity, and s is the starting height. So let's think about this for a second. This is going to be all about the graph of these functions, right? So if I were to graph this, once we know our v and our s value, what would our graph look like? Well, we know it's going to be some sort of parabola, right? Our a value is negative, so it's going to be an upside down parabola, which makes sense, right? If you toss a ball, it goes up, and then gravity brings it back down. All right, so a person is standing on top of a 50-foot building. So here's our building. A person is standing up there. It's 50 feet off the ground, and he tosses it up, and it goes down. And the starting velocity, or speed, is 40 feet per second. So let's write our formula and plug in our v and our s. So we've got h of t equals negative 16t squared plus vt. So that's our starting velocity. That's 40. And then plus our starting height. Well, he's standing on a 50-foot building, so that's going to be plus 50. So this is the formula that we're going to use to answer these questions. Before we do anything, normally we see quadratic functions when they're in standard form. It's like y equals ax squared plus bx plus c, right? So our t's are really our x values, right? And then our h of t is our y. So there's two kind of variables here. We have the time, so that's how long the ball's been in the air, and we have the height. So our time is our independent value, right? The time determines the height of our ball. Time are going to be our x values, and height is our y values. So if we want to know the height of our ball at a certain time, let's say like 2 seconds, that would just mean x, or this is t, would be 2. We plug it in there and that would give us our height. All right, let's look at letter A. It says find the time it will take for the ball to reach its maximum height. So we're throwing the ball, it reaches a maximum height, and then it falls to the ground, right? What part of our parabola is that maximum height? Well, it kind of says it right there, right? It's our maximum. It's our vertex. Now, we know our vertex is a point. It's an x-coordinate and a y-coordinate. Here we want to know the time. Well, we just talked about it. The time is our x values. So we're looking for the x-coordinate of our vertex. There's a few different ways we can do this. Since it's in standard form, we can use our formula, the opposite of b over 2a. So b is 40, so that would be negative 40 over 2 times negative 16. We can just type that in our calculator, right? Oops. Negative 40 divided by 2 times negative 16. That gives us 1.25. So that means when he throws the ball up, after 1.25 seconds, it starts going down to the ground. So it's at the maximum height. Now, how high will it be at that time? So now we want to know when our ball is at the max, how high is that? Well, we now need the y value of our vertex. So all you have to do is take our time and plug it into our formula. So we're really taking h of 1.25. So that's negative 16 times 1.25 squared plus 40 times 1.25 plus 50. Type that in our calculator, right? So go ahead and type that in your calculator. You should get 75 feet. So that means after 1.25 seconds, it's at the maximum height of 75 feet, and then it starts falling to the ground. So whenever you're talking about the maximum height or how long it takes to get to the maximum height, things like that, you're always looking for the vertex. So, of course, if we didn't want to do this way, we could graph. So let me turn my light on for this, might be a little easier. So we could graph this, negative 16x squared plus 40x plus 50, right? Our x's are, our t's are x's, that's the only difference. So let's graph it. Looks like that. So we know our vertex is somewhere up here, right? So we could play around with zooming in, zooming out. So let's zoom out. So the vertex is way up here. Let's maybe zoom in there. See if we can find it. Okay. Let's go up a little bit. Okay, so we know the vertex is somewhere up here, right? So we can do second calc. We're looking for a maximum. So we need to be to the left of our vertex. There's my cursor. Enter. Now we need to be to the right. Oh, there it is. Check that out. Our x value is 1.25 and our y value is 75, which is exactly what we got here, right? After 1.25 seconds, it's at a maximum height of 75. So whichever way you want to do it is fine. These graphs, they're not going to be like nice graphs that fit in our zoom standard normally. So it is going to take some kind of playing around with the zoom in, playing around with the window, but it definitely can be done by your calculator. All right, let's look at our last question here. Find out when the ball will hit the ground. So we need to think about, so we're trying to find the time that the ball will hit the ground. Well, think about what the height would be when our ball is on the ground, right? So our ball went up and then it hits the ground. Well, the height on the ground is 0, right? So this is the time when the height is 0. Remember, our height is like our y or our h of t here. So really what we're asking is 0 equals negative 16t squared plus 40t plus 50. We all know how to solve that. There's plenty of ways. We could factor. A lot of times these are not factorable. We could use our calculator again, or we can do the good old quadratic formula. I'm a fan of the quadratic formula, so let's do that. So the time equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Next thing I'm going to do is just find out what my number under the square root is going to be. So 40 squared minus 4 times negative 16 times 50. That gives me 4,800. So negative 40 plus or minus the square root of 4,800 over negative 32. We're going to round to the nearest tenth here, so we can just put this in our calculator and get a decimal. So we'll say 69.3. Oops, negative 40 plus or minus 69.3 over negative 32. Now we just got to get our two answers. So our first answer is going to be negative 40 plus 69.3 divided by negative 32. So negative 0.92 we'll call it. And then negative 40 minus 69.3 divided by negative 32. That gives us 3.42 seconds. So we'll always have two answers, right? It's a quadratic, always two answers. Since this is real life application, there's going to be one answer that makes sense and one answer that doesn't make sense. We're looking for time, right? To have a negative time doesn't usually make sense, right? To say that it takes negative 0.92 seconds for a ball to go up and hit the ground doesn't really make sense, right? So that one we call extraneous. So that's an answer to our formula, but it doesn't make sense in the context. So it really takes about 3.42 seconds for the ball to go up and then hit the ground. So that is kind of like the baseline of all of these problems. You're looking for the max or you're looking for the x-intercepts. So if we wanted to use our calculator for this one, it's already graphed. Now, if you look at our graph, over here, that's when the x is negative. That would be our extraneous solution. So let's look at the other one. So we need, oops, did it go by? No, I think it did. There's to the right, to the left. So there it is, 3.42 seconds. All right. Let's do one more in this packet. Let's look number 7. So 7 is going to be a very similar idea, just kind of a different situation. So number 7 says, if a toy rocket is launched vertically upward from the ground level with an initial velocity of 128 feet per second, then its height h after t seconds is given by this equation. So I'm going to rewrite it because it's kind of hard to see. H of t equals negative 16t squared plus 128t. All right, so let's answer some questions. How long will it take for the rocket to return to the ground? So if our rocket's on the ground, our height is 0, right? So 0 equals negative 16t squared plus 128t. So we could use the quadratic formula, as always, but I recognize that we can factor here. So I could factor out a 16t from both of our factors. So I get 16t times negative t plus 8. 0 product property, I set them both equal to 0. So 16t equals 0, which means t would equal 0, or negative t plus 8 equals 0. So negative t equals negative 8, or t equals 8. So we have our two solutions again. We don't have any negative time, so this one we're going to have to think about a little bit more. So if we're launching a rocket, here's the ground, our rocket goes up and comes back down, right? So there's 2 points that it's on the ground. When t equals 0, our rocket has not launched yet. So it is on the ground, but we're asking how long does it take to return to the ground. So it's got to go up and come down. That takes 8 seconds. So no negative there, but before it's launched, it's on the ground. But that's not the one we want. We want when it returns. All right, B says, after how many seconds will the rocket be 112 feet above the ground? Well, here we wanted 0 feet above the ground, right? So we can just plug 112 in for the height. So 112 equals negative 16t squared plus 128t. Now, to solve our quadratics, we always need it to equal 0. So we've just got to subtract 112 from both sides. So we'll have negative 16t squared plus 128t minus 112 equals 0. And now, of course, we could graph it. It's going to be a pretty big, wide window that we would need. So I'm just going to use a quadratic formula. All right. So go ahead and pause it, actually. See if you can figure it out with the calculator or quadratic formula, whatever you want to do. All right, so if we plug it into the quadratic formula, eventually we will get negative 128 plus or minus 96 over negative 32. So I plugged it all in, I got my answer. If we find our two answers, we would get t equals 7 seconds or t equals 1 second. So let's think about if either of my answers are extraneous, or in this case, maybe both answers will make sense. So it says, after how many seconds will the rocket be 112 feet above the ground? Technically, they're both right, because after 1 second, it's going up. So let's say this is 112 feet. After 1 second, it's right here. It's going up, it's 112 feet above the ground. That's our 1 second. And then if we're going down, on the way down after 7 seconds, it's also going to be 112 feet above the ground. So in this case, both answers work. All right, C, how long will it take for the rocket to hit its maximum height? So we want how long, so we know it's going to be time. And it's the maximum, so we know we're looking for the time at the vertex. That's going to be our x value. So the opposite of b over 2a. If we type that in our calculator, we should get 4 seconds. So it takes 4 seconds for our rocket to get up there at our maximum height. What is that maximum height? Just got to plug it in. Negative 16 times 4 squared plus 128 times 4. Type that in our calculator and we should get 256 feet. All right, that is it for quadratic applications. See you later.